Okay, so today we're going to start this unit called chemical formulas. Today we're going to start talking about chemical formulas. It has to do with the conservation of mass, the types of reactions, and predicting equations. Today is the conservation of mass. So I'm going to do it on a separate piece of paper. You guys do it on the next available page. The law of conservation of mass. Matter cannot be created or destroyed, so it's going to be equal. Whatever you put in has to come out. Okay, it's not like I put 2 cups of flour in the oven and then it comes out like bread. Cheese. Like that doesn't make sense, right? So what you put in has to come out. Maybe it's going to come out in a different shape, but it has to come out some way. So if you put 5 atoms of hydrogen, 5 atoms have to come out also. Maybe it bonded to something else, but those 5 atoms have to be accounted for. So today we're going to be balancing equations. To balance equations, balancing equations. Step 1, you're going to write the equation. The equation that we are going to be working with first is going to be CO2 plus H2O. And that is going to give us C6H12O6 and O2. So we wrote the equation, which is this one. Step 2, you're going to draw a line in the middle. So we look at the middle, that's where the arrow is. We're just going to put a line right there. Just to separate the reactants from the products. Step 3, we are going to list reactants, products, and amount of atoms. So we're going to make a list of the atoms that we have on the left and the atoms that we have on the right. So like right here, I have C. So we have carbon, we have oxygen, we have hydrogen. We have oxygen again. I already have it here, I won't list it. On this side, we also have carbon right there. We also have oxygen. We also have hydrogen. Do you want to keep it on the same level and the same order so that way you don't get confused trying to look for them? That's way easier. Okay, so on this side, on the reactant side, how many carbons do I have? Just one. It's right there. How many oxygens do I have? 2 and 1, 3. How many hydrogens do I have? 2. Okay, on this side, how many carbons do I have? 6. Oxygens? 8. 6 plus 2? 8. And then H is 12. Yes. Step 4. Look for numbers that are not the same and balance. So from here, carbon has 1, the other carbon has 6, so this one I need to fit. Oxygen has 3, oxygen has 8, I need to fit this one. Hydrogen is 2, and this one is 12, so I need to fit all of them basically. Step 5, multiply small number by a number that will give you the same number on the other side. Step 6, see if numbers match. Basically, here's what you're going to do. First of all, rule number 1, you can never, ever, ever change the little numbers. Okay? If you change the little numbers, you're going to change the whole identity of the compound. So, you will never, ever change the little numbers. You can only change how many molecules you're going to put in there. So you're only going to change the big numbers in front. That means like I'm going to get 2 CO2s, I'm going to get 3 CO2s and things like that. Okay? So the numbers in front, those are the ones you're going to change. And those are the ones we're going to figure out right now. Let's work with C first. We have C. Which side has the lowest amount of carbons left? Okay, so I'm going to work with the C over here. And it's right there. What number multiplied times 1 is going to give me 6? 6. Okay, that's going to change my C. 6 times 1, 6. But that's also going to change my O. So the amount of O's I have, it's going to change. Now I have 6 times 2? 12 plus 1 over here? 13. Well, what's 12 plus 1, guys?
17.
13. 13, very good. Okay, so there's 13 O's as of now. Now, honestly, odd numbers kind of scare me. I'm going to see if it figures itself out. So we're going to work with H now. Which side has the lowest amount of H's, left or right? Left. So I'm going to go with the H on this side. What number multiplied times 2 is going to give me 12? 6. So 6 times 2, 12. But that's also going to change my O's. Now what's 6 times 1? 6. Plus the 12 I already had over here. 18, there you go. So now I have 6 C's, okay, that one's fine. We have 18 O's, that one still needs work. 18 and 8, that one needs work. H, we have 12 and 12, that one's okay. Okay, so I need to work on my O's. I could put it here because there's an O right there, but there's also a C and an H. I don't want to mess with those because, I mean, they're already right. On this side, I already have the 2 by itself, so I'm going to put the number, whatever it is, to try to fit the O's right there. Okay? Okay, I need to get to 18. I have 6 over here. What's 18 minus 6?
18 minus 6.
12. There you go. Okay, so I need this whole thing to be 12. What number multiplied times 2 is going to give me 12?
6.
6. So 6 times 2, 12 plus 6, 18. Now it's right.
The devil's number, 666.
Yeah.
That's
But, I
very
mean, it's
unfortunate.
6, 6, 1, 6. Like,
Damn,
ha, almost. Questions there?
he got you.
No?
He.
Let's do another example. We have
I just assumed
H2
the double standard.
plus O2 gives us H2O. Step number 1, we're just going to make a line. Step number 2, we're going to make a list. H-O. H-O. How many H's do I have? O's? 2. On this side, how many H's do I have? And O's? 1. Which one do I need to fit? The O. Okay. On which side am I going to go, left or right?
Right.
Right. Okay. What number should I put in front? What number multiplied times 1 is going to give me 2? 2. Okay. So this is going to change my H. 2 times 2 is 4. And then 2 times 1 is 2. So now my H is changed. So I'm going to work on my left-hand side, the H. What number multiplied times 2 is going to give me 4?
2.
That's it. We're good?
2, 1, 2.
2, 1, 2. Last one, because there are several problems like this in your assignments.
Assignment?
Assignment, yes, there's an assignment. Okay, we have rubidium nitrate, and we mix it with beryllium fluoride, and we're going to get beryllium nitrate, I cannot pronounce that, and rubidium fluoride. That's an F. RBF. It barely fits. Step number 1, make the line. Step number 2, make a list. We have rubidium, and then we have nitrate. Now, this one, nitrate is a polyatomic ion. Notice how there's 1, 2, 3 elements right there. Nitrate is its own little group. To make things easier for you, do not separate it. Just leave it as NO3. I mean, if you want, you can use like N and O, differently, like just make a list of N and O. But since right here I have NO3 and on the other side I also have NO3, I just figure it's going to be way easier if I just keep it as NO3. Okay? So NO3, and then we have beryllium, and we have fluorine. Same thing on the other side. Okay, rubidium, how many do I have? 1. Nitrates? 1. Nitrate again is its own thing, so there's 1. Beryllium was 1, and fluorine 2. On this side, rubidium 1, nitrate 2. When you have the parentheses like that and there's a number on the side, it's the number on the side. Then beryllium, there's 1, and fluorine, there's 1. Okay, next step, figure out which ones I need to change. So I need to change NO3. I need to change fluorine. So let's start with NO3. On this side I have 2, on this side I have 1, so I'm going to go to the one that has lowest. So it's this one right here. What number multiplied times 1 is going to give me 2? 2. Now, I cannot just put it here. I cannot put it here. I have to put it at the front of the whole compound. So it's going to be here, 2. So this is going to change my rubidium, and it's going to change my nitrates, like that. What's going to change is fluorine to 1. So I need to change it over here in this fluorine right there. I cannot put it here, I cannot put it here. I have to put it at the front. What number multiplied times 1 is going to give me 2? Yeah, 2. So this is going to change my rubidium. And this is going to change my fluorine. Rubidium, fluorine. So now let's check if the numbers match. Rubidium, rubidium, 2, 2. 2, 2, 1, 1, 2, 2. Okay, so that's how you balance equations.